Hello and welcome to the section 9.3 lecture today for flipped algebra 1. Today we're going to be looking at some more exponent stuff and more importantly some non-positive exponents. And we want to simplify expression with non-positive exponents. Non-positive means, let me get my pen on the right page here. Non-positive means 0 and negative. Okay, that's specifically what non-positive means. So when we want to look at this, if I actually calculate these out and I figure out what these are, 2 to the 5th is 4 times 4 times 2 is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared is 4, and 2 to the 1st is 2. So if we continue that list and we continue in that kind of negative direction, what do you think we're going to get? If everything is right, and if our math is right, we should be able to follow a pattern. What is the pattern as we move this way? What are we doing every time to get the next number? Okay, 32, to get from 32 to 16, that sounds like dividing by 2. 16 to 8, divide by 2. 8 to 4, divide by 2. And 4 to 2, divide by 2. So to get to 0, it should be 2 divided by 2, which is 1. 2 to the negative first power should be 1 divided by 2, which I guess I would call that 1/2. 2 to the negative 2 is going to be 1/2 divided by 2, which would be 1/4. And 2 to the negative third would be 1/4 divided by 2, which is 1/8. Okay. So to get some rules out there is for the 0 exponent rule, any number, I'm actually just going to use symbols for time, any number to the 0 power is always equal to 1. Okay, and it's because of how this list is built that whatever number, and we use 2 in this case, but whatever number you have that you're looking at exponents of, in order to go down in an exponent, you have to divide by that whole number, that number that is being affected by exponents. So, 2 divided by 2 is going to give us 1. And then something that's a little bit harder to see, but we can see it, is that if we look at the ones that ended up as fractions here, and the 1/2 is 1/2, but the 1/4 I could actually write as 1/2 to the second power. And the 1/8 is 1/2 to the third power. So if I relate this piece to what I ended up with, it looks like a rule for negative exponents. Any number to a negative power is going to equal 1/, that number to the positive power. So the exponent stays the same, it just goes into the denominator. Okay, and there's actually a way that you could kind of see this in action based on things that we've already talked about. And what I'm really looking at here would be like any number to the 0 power, which I know that's 1, and then any number to the n power. We talked about the quotient rule yesterday, in that this would simplify to a to the 0 minus n, and 0 minus n is negative n. Okay, so that's kind of where that rule comes from as well. But also, we just see that repeating pattern. We see that repeating pattern that we get. So what we're going to do today is try to simplify some of these by writing only positive exponents. I do not want zeros as exponents, and I don't want negatives. Okay, and there's a couple ways that we can do that. The first thing that we can do on this one is I could just say, oh, that's a negative exponent. That's supposed to go on the bottom. So I could say that this is 3 times k to the 7th over k to the 4th. Any negative exponent should just be written in the bottom. Now I can do some simplification using my quotient rule. I would subtract those exponents. Okay. Now, if you would rather not write that down below, that could have just been 3k to the 7 plus negative 4, right? Because that's kind of a product rule there. We're multiplying things with the same bases, with k as the base, and 7 plus negative 4 would give us that same answer. So you kind of have two options there. Pick whichever one. I use this one because that's what we just talked about. This next one, I have some zeros involved. And what I'm trying to get across here is this doesn't mean that this equals 1 times 1, right? Because the 4 and the 3 still exist. And they don't have exponents on them, so they automatically have 1 as their exponent. And that 0 doesn't travel to that. So this turns out to just be 4. Oops, not 2. 4, come on, times 3. Because the a to the 0 goes away, a to the 0 goes away. And by go away, right, I mean it equals 1. And multiplying by 1 doesn't do anything for us. Okay, that can also be seen in this next one where I have this whole thing raised to the 0 power. When I raise this whole thing to the 0 power, that's going to mean all I'm left with is 1. That's all I have. On this one, the whole thing's being raised to the negative first power. Well, yes, this is like a power rule going on here where we would kind of want to distribute all these. And I could say this is 2 to the negative first. 4 times negative 1 is negative 4. 3 times negative 1 is negative 3. And 7 times negative 1 is negative 7. I could do this, but then I also have to think about all these are negative, so they're all going to go in the denominator. 2, x to the 4th, y to the 3rd, z to the 7th. And that's just following the rule of negative exponents. Let's look at how bad some of these can get. Same types of problems. We're doing the same thing. We're trying to simplify it using kind of all the rules that we've talked about. And since we're kind of only dealing with multiplication, you can kind of mix up what you do a little bit. You can use some different ideas. I'm going to sort of think about distributing this power to these two things. And again, I do have to multiply those. So that's going to be 2 to the 1 times 4 is 2 to the 4th. Excuse me. R to the negative 4 times 4 is negative 16. And on the bottom, I can combine these two to give me r to the 5th. Now, before I think about doing any quotient rule stuff, I do need to have this have a positive exponent. So I'm going to bring that into the bottom. And now I have more that I can combine in the bottom. And that's going to be r to the 21st power. And that's all I can do. All right. Next one, I've got a lot of negatives, but I'm going to sort of simplify some things before I get too crazy with it. I'm going to leave this b to the negative 2. I know that it needs to go in the bottom, but I'm going to deal with this part first. 2 has to be raised to the negative 1 power, and b actually turns out to be negative 3 times negative 1, which is positive 3. So that one's actually okay. I'm going to end up moving a b squared to the bottom and a 2 to the bottom. Okay, so let's go ahead and do that. On top, I'm going to have 2b cubed and another b cubed. So that's going to be 2b to the 6th. And on the bottom, I'm going to have 2b squared. The 2's cancel. Quotient rule here, I'm left with just b to the 4th because 6 minus 2 is 4. This one here that kind of got a little crowded with that one, I guess. I'm just going to take this whole thing here and move it into the bottom without really distributing it, because that's what I can do when I have a negative 1 there. So I'm going to have 2x to the 4th over 2x to the 4th. And everything there is going to cancel out. I'm just going to have 1. That could also be seen if you were to distribute, if you happen to distribute that exponent and then use product rule, you would have gotten a couple things to the 0 power. Okay. Let's look at this one. Let's see. On the top, I just have that 1p. On the bottom, I have a p to the negative 4th down here. And then this is going to turn into a p to the negative 8th. So, and then I got another p there. I can just go ahead and cancel those out first, as well as kind of organize the bottom of this a little bit. I have 2p to the negative 4th power, and then I also have p to the negative 8th power. I could use product rule here. I don't know if I necessarily would first, but I definitely can, right, to give me p to the negative 12th, because negative 4 plus negative 8 is negative 12. And then I need to pull that p to the 12th up top, because I can't have any negative exponents. Okay, last 4 problems it looks like. Yeah, it gave us plenty of room to do that. That's good. Everything on the denominator on this one goes to 1 because of that 0 on the outside. This x goes to 1, so I'm going to have 2 x to the negative 1st power over 1. And that x to the negative 1st is going to put that on the bottom to the 1st power. And so I have 2 over x. Okay, next one. I just try to get rid of anything I can right off the bat. Any zeros that I see, I try to get rid of those. I think the next thing I'll do is sort of distribute this 4th power into there. So on top, I'm going to have x squared. On the bottom, well, I'm going to pull this y squared up too. So I'm going to have x squared, y squared on top. On the bottom, I've got that x hanging out in front. And then 2 to the 4th, x to the 3 times 4, which is 12. And y to the negative 4 times 4, which is negative 16. I've got these x that I can combine, x's that I can combine. And then I'm going to bring that 16 to the top. Okay. So I guess I'll just go ahead and write that. Y squared, y to the 16th. And then that's going to be over 2 to the 4th. That looks like x to the 13th. Oh, excuse me. Y's, I have 2 and 16, so that's going to be y to the 18th. And then x's, quotient rule says to subtract them. It says to go 2 minus 13, but that's going to give me a negative. So I kind of think of quotient rule a little bit differently, in that I'm going to take the bigger exponent, subtract the smaller one from it, and put where, think about more of the canceling out method. If I cancel out 2 x's from each side, I'm going to have, from each top and bottom, I'm going to have 11 left on the bottom, none on the top. So I'm going to get y to the 18th, because 2 plus 16 is 18. 2 to the 4th, x to the 11th. And that's what I get from that. Next one here. I know, they're getting ugly. They're definitely getting ugly. Okay. Let's see what we can do. I can bring the y up and bring this x down. When I bring the y up, I can even combine it with that y to the 4th. We're getting really crazy here. On the top, I see y to the 7th. On the bottom, I'm going to leave that 2. I'm actually going to bring that 2 out in front and say 2x squared. X to the negative 1 times 4, that's going to be x to the negative 4th. Y to the 4 times 4 will be y to the 16th. And so it looks like I've got some x's to deal with and even some y's on the top and bottom. If I use product rule right here, it's actually a little bit easier because 2 plus negative 4 is negative 2. So I can say y to the 7th over 2x to the negative 2, y to the 16th. Now I'm going to move the x to the negative 2 up and use the modified quotient rule on the y to the 7th over y to the 16th. That's going to leave 9 of them on the bottom, and I'll have 2 x's on top. I have 2y to the 9th. Okay. Last but not least, I've got an ugly one. I think we're going to try to simplify inside the parentheses before we try to pull that 4 into everything. I'm going to hold on to this outside 4 out here because I do have a lot of weird stuff going on in here, and I can definitely simplify that. So I've got u's and v's, which also I'm dealing with trying to tell which one's a u and which one's a v. So I've got v to the 3rd, v to the 2nd, and v to the 1st. 3 plus 2 plus 1 is 6. And I have a u squared right there. So I'm going to say 2u squared v to the 6th. On the bottom, I have the product rule of v to the 8th. And then all that will still be raised to the 4th power. We can do a little bit more simplifying. I've got a v to the 6th on top, v to the 8th on the bottom. So I have more v's on the bottom. I'm just writing that 2u squared. More v's on the bottom, there's 2 more of them. And then I'm going to take that and raise it to the 4th power. When I raise things like this to the 4th power with all multiplication and division, I raise everything to the 4th power. So 2 to the 4th, u to the 2 times 4, which is 8, v to the 2 times 4, which is 8. And that'll be it. Okay. Make sure you summarize the notes. I'm going to say for homework-wise, give you something. We're going to focus on, I guess, 3 and 4. 3 and 4 in the application, and let's do 2 to 12 even here. So we're going to say homework, practice, number 2 to 12 even, application, number 3 and 4. All right. Make sure you write any questions you have on the left side and ask those when you get to class. Otherwise, I hope you have a great day, and we will see you next time.